jump around a little bit. So when we're keeping things together, remember there's a zoom in, zoom out. So if you go to 17, this would be zoom in. This is zoom out. Zoom in, zoom out. If you take the other example that followed, I would call this zoom in, but you always, at the end of the day, you zoom out. Zins out. How's that? Okay. You gotta figure out the permutations, the rearrangements within that small group that is staying together, and you need to then at the very end zoom out, consider all the groups you've made as one tile, one slot that you're moving, right? And then just consider that you can also move those three, in this case 3 around. Okay, so let's keep going. I'm gonna try, we're just gonna do the dog example because the do not sitting together, I'm gonna probably do it faster than. So if there are no restrictions, you've got 8 dogs and 5 cats, how many ways can they be arranged in a row? We've got 13 total, right? If there are no restrictions, it means you can have dog, cat, you can have them any which way, right? So everything, we're considering everything. So it's basically 13 factorial, right? Or you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then you just go like this. If you like the fundamental counting principle, you do this, no problem. Okay? So keep that in mind. If you have to keep all dogs together, there's 8 of them. So you go 1, 2, 3, 4, 5, 6, 7, 8. And then it's 1, 2, 3, 4, 5, right? So these all have to be kept together. So you have your zooming in. So within that group that must stay together, it's 8 factorial. When you zoom out, you consider this one long spot that you can move around, right? You can bring a cat over to this side. You can bring 2 cats over to this side. So this tile would shift over. So when we zoom out, we have 1, 2, 3, 4, 5, 6. So 6 factorial. So in a sense, we can say 6, 5, 4, 3, 2, 1, right? 6, 5, 4. So that's how the 6 factorial comes to play here. So 8 factorial, 6 factorial in this case. All cats are kept together. 1, 2, 3, 4, 5. I'm going to start with them, and then 1, 2, 3, 4, 5, 6, 7, 8. I only care about the cats staying together. So within that group, there's 5 factorial permutations, so 120, right? Ways I can move them around. And then I need to go, right, count this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 9, 8, 7, 6, 5, 4, 3, 2, 1. So this ends up being 5 factorial times 9 factorial. Can you do the pick? Can you do permutations? Yes, 5 factorial is what? 5 pick 5, 9 pick 9. I don't need to do that. I think it's a little irrelevant. It's tedious, so I'm just going to leave it at that. Dogs sit together and cats sit together. So now you're making 2 groups. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So you're keeping the dogs all together, 8 factorial. You're keeping these all together, 5 factorial in that group. And what's your zooming out here? 2, right? Because there's this big tile here and that big tile there. So it's just 2, 1. Okay? So we go 8 factorial for the dogs, 5 factorial for the cat, and then 2 factorial is your zooming out. That is, to be honest, that's the one that students miss most often, is that last piece where they have to zoom out and figure out how many tiles there are if you zoom out of the groups. Okay, this is the one that most students miss. Okay, dogs sit together, and Manfred and Belinda, both cats, sit beside each other. So you have to make sure that you understand that the question will hint towards them being together in different ways. It won't always say be together. They'll be beside each other, right? So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So we know that the 8 is here, right? That's 8 factorial. Just make sure. Yeah. And then Belinda and Manfred, right? Those are 2 cats. Okay, so we've got 8, 2. So that's for sure. 8 factorial, 2 factorial. No questions about that. But now you count, right? 1, 2, 3, 4, 5. So this is 5, 4, 3, 2, 1. So it's 5 factorial at the end to get that one right. And I'm not giving you the answers because right now that I hope you know how to do, how to type this into your calculator. You should be able to figure that out. Now, Manfred and Belinda do not sit together. Not, think of it this way. Remember not sitting together? Together not. Remember set theory? What do you do when there's a not and on top like this? We go universal minus together. Please tell me you remember that. Right? Just keep going, right, Mr. Erickson? We're tired. I don't want to hear it, right? Just give me the answer. Okay, universal is A. It's 13 factorial minus them being together. We just did that. Oh, I have to be careful.
We need a custodian to the office, please. A custodian to the office with a trolley.
I did this on purpose when I wrote this because you're like, oh, they're together here. Let's just subtract that answer. But we care about the case where those 2 are together. Okay, those 2 only. So together, let's do that one. Together would be, it's going to get messy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the 2 being together is 2 factorial. This is together. Okay, 2 factorial, and then you zoom out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 factorial. So really, them being together is 2 factorial, 12 factorial. This is what we need to subtract from 13 factorial. That's the short version of doing it. If you'd like to calculate that, right, and then calculate the other and then subtract, that's fine. I think I can give you that. This is 5 billion 269 million 17,600. Okay. This is a big number, but your calculator can handle that. And so the pages that I assigned, 21 to 23, kind of from time to time you came across things being kept together. I think there was a library one, books being kept together, things like that. Same idea. Okay. Anything from pages 21 to 23 you need me to clarify? Yes, Filbert. Question 13. Don't tell me that it's one I don't like. Yeah. That one I don't mind. Thank you for picking that one. Nobody had a problem with question 10? I think 10 is 9, 10. I'd say those are all kind of, you gotta watch out, you gotta read careful. But let's do this one first. I'm gonna stop the video.